Hi, welcome to this LangChain course. This course is the most complete course on LangChain you will find on YouTube. After this course, you will be able to develop complex applications with large language models and use them for your own purpose. We start with a simple introduction to working with LLMs, first without LangChain, and then we look at LangChain and why LangChain makes your work so much easier right after. After that, we go into the topic of templates and response schemas, and look at so-called chains and also at output parsers, which allow us to adapt the output of LLMs to our own purpose. After these basics, we will look at more complex use cases for chains, so-called SequentialChains and RouterChains. After that, we will take a look at the concept of memory that LLMs can use to pay attention to the context of a conversational history and not just respond to one direct question. Next, we'll move to indexes, where we'll look at how you can tap into your own knowledge base and use vector databases to extract data via similarity searches and send it as context to an LLM. After that, we will move to more advanced chains, the so-called agents, which are able to autonomously perform tasks and use tools to do so. In this context, we will also look at how ChatGPT plugins work under the hood. Finally, we will also learn how to evaluate the output of LLMs, because there's no standard metrics like in classic machine learning, and this module is still in beta phase. I hope that sounds interesting. If yes, stay tuned, we will start coding together right now. Okay, we start with the very basics. You will find the link to my repository with all of the notebooks in the description. To make this repository work, you need an account at OpenAI, so at platform.openai.com. Create an account, and after creating an account you have to go to Personal and then to View API Keys. And there you see all of your API keys. To create a new one, you click on Create New Secret Key, click here, and then you just copy the key. And then you create a .env file, like here, and copy the API key here. The key has to look like this, OpenAI _API _ key, and then the API key here. I'm here at Visual Studio Code, which makes working with IPython notebooks pretty easy, and we start with the model basics.ipython notebook. First, we have to install some packages like python.env to read our environment variable and also install the package OpenAI. So just click here, and then you have to pick a Python environment, and I'm just gonna use my Python 3.11 environment to install the packages here. Okay, this takes a few seconds, and after that we can just load our OpenAI API key as property from our environment file. So let's gonna do this. Okay, here you can see now a little helper function called chat, and we've got a messages array here, and inside this messages array or list we've got a dictionary with a key role and a value user and also content, and the value here is the parameter which will be passed to the chat function. We take this messages list and pass it inside the create function of the chat completion class from OpenAI, which will make a request to the OpenAI API. The response object is a complex object. We can access the actual message which we receive from OpenAI with response, and then we've got an attribute called choices, which is a list. We access the first element, and this has another attribute called message and a key content. So what we return here is just a text which we receive from OpenAI. Okay, let's run this. And then we use the chat function, what is the capital of France? And here we just return the output. And now we make the request and get the response. The capital of France is Paris. So this is a very basic example. We ask one question and get back an answer. But oftentimes we want an LLM to behave in a very specific way. For example, like here is our question, what is the capital of France? And then here is our prompt, and we also want to send this text to the API. So this is the behavior we expect from the LLM. Be very funny when answering questions. And here we can see our question, and this is just a multi-line string with one variable, and the variable will be the question here. So we do this again, and now we want the LLM to behave differently and be very funny. So as you can see, that's an easy one. The capital of France is obviously, wait for it, the special AI humor. And as you can see, this works. It behaves differently than before. Okay, I guess that was not too difficult, but to be honest, this function here is not the easiest one. You have to know that the OpenAI API expects the messages in this format here with a role and the role is called user and the content looks like this. And then you create a function call with the model, the messages and the temperature, and that the output looks like this. So not very difficult, but you have to know the documentation to use it. This can be done easier with LangChain. Now we go to models, prompt and parsers, and here we first install the LangChain package. We have to use our kernel again, and this also takes a few seconds. And after installing it, we just have to import some classes like the OpenAI class and also the LLMChains class. But we first have to load our API keys again to make this work. And then we use the OpenAI class and we pass in a model name to the constructor, which will be TextAda001, which is a very cheap model. And we ask this model to tell a joke. As you can see, this is a single line of code and we don't have to know the expected input for OpenAI. So we can just run it and we get back a joke. Okay, why did the chicken cross the road to get to the other side? So again, very funny. And as you can see, this was pretty easy to use and we don't have to write a helper function to talk to OpenAI. Before we used a multi-line string to manipulate the behavior of the LLM, and we again want to do this here, but now we're going to use the prompt templates class from LangChain, and we first have to create the template, which will still be a multi-line string. And here we have interpret the text and evaluate the text. So we've got a sentiment here and we want to interpret the text as positive, neutral or negative. So this can be done, for example, in a review for a product like in a pizza store. And then we also want to extract the subject here from this message. And we want the bot to return that in a JSON format. So this sentiment here and the subject. And then we've got the input variable. And yeah, this will be handled by the LLM. And we're just going to run this. And then we import the chat prompt template class. And we create our template with a class method from template and pass in the template variable which we created here. So now we've got our prompt template. And now we also have got a chain. This LLMChain class makes it even easier for us to interact with OpenAI. So we just pass in the LLM, which we created here. So this is just an instance of the OpenAI model TextAda001, and the prompt, which is just the instance of the prompt template which we created here. So and then we can just use from the created chain instance the predict method and input I ordered pizza salami and it was awesome. So if you run this, we should get back this output in a format which looks like JSON, but actually it is just a string, but the LLM does its best to format it in the expected or requested way. Okay, here you can see I ordered pizza salami and it was awesome. And we can also see the subject and also the text. But as you can see, that's not a perfect valid JSON format and we've got some more text which we normally don't want to have here. I will just show you how to get rid of this text, and this can be done with an output parser. So we're now gonna make a little more complex example with a response schema, templates, chains, and also an output parser, which will handle the way or a better way how we get back our response and make it even easier to interact with the LLM. To achieve this, we first have to import the response schema class from LangChain and also the structured output parser class from LangChain. And then we create a response schema. This is a new property here, the price, and before we had also sentiment and subject, so this isn't new. So we give it a name and we also give it a description. So this is the same like here. For example, this is the description and this is the name of it. So here is the name and the description is the text positive, neutral or negative. So just a little description for the response schema. And we do this for all of the three keys we want to have, like sentiment, subject, and price. So after that, we create a list of these response schemas. After running this, we pass the list of response schemas to the structured output parser class, and we run the class method from response schemas and pass in here our list of response schemas. And this gives us back an instance of a parser. And now we can use the get format instruction method here. And as you can see, So as you can see, we get back here, the output should be markdown code snippet formatted in the following schema. And then you can see that we have some triple backticks with a JSON format, and we've got the sentiment, and then this is the key. And after this, 2 double backslashes, and this is the description of the response schema, and so on and so on. And yeah, that's our new template, and we created it by using this response schema. It adds just a little more context to make it even easier to interact with the LLM. Okay, and this format instruction text here we have to use in our template. So again, we create a template, interpret the text and evaluate the text. So nothing new, we just create it like this. And then we've got the input text and also this format instruction. So the format instruction will be this input here, and we pass it to this template. Okay, after creating the template, which will be also done with the from template method here again, we've got our prompt. And then we run from Parser the get format instruction to receive this text again. And then we pass all of this to the prompt class, and we run the format message here. And its input, this will be our question, or not our question, but our review from the user. And as format instruction, we give just this format instruction here. Then we've got our messages, and we just create a new chat instance with the chat OpenAI class. And we pass in all of these messages here to this chat function. And then we get a response here in hopefully the correct way as we expect. Okay, to make it actually work, I had to add this line here. Just return JSON, do not add anything, no interpretation. So before I also received some additional text, and this cannot be parsed to the output parser then. So we just now have our AI message and the content here, and we pass this to the parser, and this will give us back a dictionary. So we run this here, and then we can see the sentiment is positive, the subject is pizza, and the price is $9.99. So this output here could now be used to, for example, to be inputted inside a database. Okay, this example was not too easy, but our chain in general was pretty easy. We've got an input text and just an output. But there can be more complex chains. For example, if you want to chain multiple chains together, so you put in input inside the LLM and take the output back inside another chain. And this can be done with more complex chains. We have a look at different chains here in the chains IPython notebook. And again, we just have to import here our API key, and then some additional classes like prompt template, OpenAI, and the LLM chain. So first we run our very basic example here, and this is what we had before, and it's not the more complex way. We just want to return some JSON format here. So we run this and predict I ordered pizza, and we get back the sentiment and the subject. So this is fine, but we normally could now pass this output here to another chain, and this can be done with a so-called sequential chain. For example, we've got a response template here. You are a helpful bot that creates thank you response text, and if customers are unsatisfied, offer them a real-world assistant to talk to. So we use this template to create a new review template instance. So we've got the LLM again, which will just be an instance of the OpenAI class here. And now we've got our review chain. Okay, what we're going to do now is we want the output of this chain to be passed to this chain here, to the review chain. And to do this, we can use the simple sequential chain class here. And we give it the chains argument in the constructor, which will be a list of our chains. So the first chain is the normal chain, and the second chain is the review chain. And now we've got an overall chain, and we just call the run method. And here is our question. I ordered pizza and it was all full. So normally it should be evaluated inside the review template, and we should now get back text here. For example, this is the subject here from the first chain, and this is the review chain. I'm sorry to hear that you are unhappy with our pizza. Please reach out to our customer service. So everything works as expected. We've got our first chain, and then we pass it to our second chain. So chains can be even more complex, and not all chains will be as simple as passing a single string as an argument and getting a single string as output. So we've got a more complex chain here now, and we have to import the sequential chain class to be able to work with it. And as you can see, we've got a template with the dish name and the experience. So we've got two inputs here, and we want to pass the output of this chain to another chain. Given the restaurant review, and the review will be the output here, and we have to define an output key to make sure that this review will be inputted inside this variable here. So output key has to match input variable name here. So we pass it from here to the second chain and the output here to the third chain, and then we want to write a summary in the fourth chain. So then we instantiate our sequential chain with the chains, the review chain, the chain comment, the chain summary, and the chain translation. All of our 4 chains as a list here. So the input variables will be dish name and experience. So just for the very first chain. Everything else will be handled by the LLM. And we also have to define the output variables, review, this is the output key here, comment from the second chain, summary from the third chain, and then German translation. So all of our output keys have to be defined as output variables in our chain. And then we run the chain, not just as a string now, because we have multiple inputs, so we have to define a dictionary, the key with a key, which has to match the name of the variable. So dish name will be pizza salami, and the experience will be it was awful. And if you run this chain now, this may take a few seconds more because we make 4 requests to OpenAI, and we can see pizza salami, it was awful, and the review, I recently ordered pizza and it was extremely disappointed. The pizza was dry and so on. So the LLM made that up for our experience, which we provided here. And then our comment, I'm sorry to hear that. And then the summary, this restaurant's pizza was of poor quality and not worth recommending. So this is just a short form of this review here. And then we've got the German translation. Diese Pizza des Restaurants war von schlechter Qualität und ist nicht empfehlenswert. So this also worked. So as you can see with the sequential chain, you can even build more complex chains now. But not all chains are just sequential chains. For example, we've got our restaurant and we want the LLM to behave differently when we have positive input, neutral input, or negative input. So we some kind of have to route our output to different kind of chains. And this can be done with a router chain. You can think of a router chain like an if-else case in just normal programming. So to make this work, we have to import another class here, the multi-prompt chain class from chains.router. And we also have to import the multi-prompt router template from the router multi-prompt. So now we've got 3 templates, a positive template, a neutral template, and a negative template. So this template will be used in the second chain of our LLM. The first template will then decide if the review was positive, neutral, or negative and route to one of these templates. So what we're going to do now is just import the classes and create the variables here. Okay, after creating it, we have to create a list of the templates and we have to provide a name and also, very important, a description. So we have to tell the LLM what this template is good for. For example, good for analyzing positive sentiments, good for analyzing neutral sentiments, and so on. So we've got the name, the description, and the actual prompt template. Then we create an instance again of OpenAI just to have an LLM. And then we just iterate over the prompt infos list and create a more complex object like a dictionary. And each of these dictionaries again has a single LLM instance here and also a single template here. So it looks like this if you run it. So here is the dictionary. The positive has a LLM chain and also a single prompt template, neutral the same, and also for the negative. So, okay, after creating it, we can just get the informations here from the prompt infos list and get back the name and also the description. And this will be passed as destinations. As you can see, we make a new line here. So we've got first the name and then the description on the second line. And we pass this destination string here to the multi-prompt router template. So this will also create some text for the prompt. And then we use the prompt template here and pass this router template as template here. And also we create an output parser and we use a predefined router output parser, which helps us to actually route the output of the LLM to one of our LLMs here. So this is the first input and this is the second input. After this, we will create an instance of the LLM router chain. We use the class method from LLM here, provide our LLM and provide also our a router prompt. And after this, we will create an instance of the multi-prompt chain, which takes an argument, which is the router chain here, and also the destination chains. These have to match the following format here. So we've got the dictionary, and this is the first chain, second, and third. And then we also have to define a default chain, and we use a neutral chain as the default chain, and also give it verbose true to get more of the output in standard output. So now we run chain.run, and we'll just say I ordered pizza salami and it was awesome. So it should normally fall in the positive category. Okay, that worked. As you can see, we've got the input. I ordered pizza and it was amazing. The LLM rated it as positive. So this was routed now to the positive analysis route, and the customer enjoyed their pizza. They found it to be amazing and for it a great place. So this worked. We get back the output here from the first chain and then route it to the positive chain. And yeah, you can use these router chains to output chains conditionally to other chains, which just gives you more flexibility to create even more complex applications. Okay, after taking a look at chains, we will now take a look at memory. Memory is some kind of different concept and is very useful for applications, for example, like chatbots, where it is important to remember a previous interaction to keep the whole context of a conversation. And the memory classes from LangChain gives you an easy way to handle this. Again, we will just import here our environment variable. So first we take a look at what happens under the hood, and under the hood in memory is used the chat message history class, and here we're just going to import it from langchain.memory and instantiate it. And then we have multiple methods like add user message. This is the message from a user. And we can also add an AI message. And this is the message normally which comes from the LLM. So we're just going to use this here. And as we can see, we've got now a list with a human message class and the content is hi, and also an AI message with content hello my friend. To use that memory for our purpose, we can import a new chain called ConversationChain, which makes use of memory. Not all chains are able to use memory under the hood, so we have to use the right chain. First, we create an LLM, just an instance of OpenAI, and then we instantiate the conversation chain with the LLM and also with an instance of the conversation buffer memory. And now we can just run the predict method and say input equals hi. Okay, here we can see the input is hi and the AI responds with hi there, how can I help you? Okay, now if we run another predict method here, I need to know the capital of France. Then we can see this is the current conversation. Hi there, human, I need to know the capital of France, and the AI responds again. So we just run the predict function, but under the hood, the conversation chain stores all of our messages and provides the whole conversation as input to the LLM again. So this works fine for our use case here, where you have some simple kind of questions and answers. But if you have more complex conversations with more words, we may exceed the maximum input tokens for the LLM. So instead of just giving the whole conversation as context, we can use a different kind of chain. And this is the conversation summary memory. And this will just summarize the whole conversation first and only send the summary of the conversation to the LLM or OpenAI. So here we have to install another package called ticktoken. We're just gonna install it here. And then, for example, here is the conversation buffer memory, and we've got some review. So instead of ending this whole review with the conversation, we can create some kind of mock conversation here with safe context, where the input is hello, I can help you today, and this is the output. We just want to send a summary of this conversation. And we can do this. We're just going to run this code here. And then we run the conversation chain and just run the predict method. And as we can see, here is our conversation. So we don't have this whole conversation inside the prompt, but only this kind of system message. The human asked how they could help the AI, and the AI requested an analysis of the review. So this is just a summary in one sentence of this whole conversation. So this is much cheaper for us to actually make a request to the API, because the costs are calculated by tokens, and of course we don't have the problem of possible exceeding the token limit for the request. Okay, next we take a look at indexes. Indexes help us to overcome the exact same problem as with the conversation buffer memory, or better said, the conversation summary buffer memory, where we reduce the context in the LLM to exceed the maximum number of tokens. Indexes are also very helpful when you have a knowledge base, for example, like a database or some text files, which are not trained into the LLM, and you need to retrieve information and send it to OpenAI to get back a human-like response. For example, we've got some FAQs where we have questions about our restaurant, and we can see when the restaurant is open, and also, for example, like some special ingredients, allergics, and so on. This is all information which was not trained in the LLM before. So what we're gonna do here is to create, of all of these text files here, we create a vector store, and the vector store stores these text inputs in so-called vectors, which are just a list of numbers. I'm gonna show you that on the OpenAI website, which displays pretty nicely. So here's the website. And as we can see, here we've got text, and this text will be passed to a so-called embedding model. The embedding model is responsible for converting the text to a vector. A vector is just a representation of text as numbers, as a list of numbers. And now you can store this list of numbers, the so-called vector, inside a vector store. And for example, this looks like this. There's even a better explanation down there. So we've got similar vectors stored in similar places in the database. For example, vectors which belong to animals are stored in this space, and vectors which belong to athletes are stored here. And then we make a query to the database, and the query gets also embedded, and now we make a similarity search. For example, we want to get the top 5 similar vectors in the vector database. And we also know which vectors belong to which text. So we can take the top 5 texts and pass the text as context to the LLM. And I will show you how to do this now. Okay, let's go to indexes, IPython notebook. And again, we also have, of course, to install some packages first. And what we're going to do here is install the FICE CPU package and also the pickle package. And the FICE CPU package is the vector store, which allows us to store the vectors in a database. And the pickle file will help us to serialize the database and store it on our file system. So we're just gonna install this and then run, again, loading the API key. Okay, and then we take a look at the first concept here. The first concept are loaders. So we have our text here inside a text file, and we could also have it in a CSV file, we could have it in a PDF, in an email, or a SQL database. So this is just our knowledge base, and LangChain provides different loaders which help us to retrieve the information from these files very easy. For example, I use the directory loader and also the text loader. The directory loader helps us to define a single directory. So this is where all our files are stored. And then we make a recursive search for .txt files. And then we use the loader class for every item which is returned by the directory loader and pass it to the text loader. So we see when running this that we've got 3 files here, 3 of 3 were loaded correctly, everything works as expected. 3 of 3 because we've got 3 text files here. We will not just put all of our text to embeddings, but we will provide smaller pieces, so-called chunks. And you can define the chunk size and the overlap between the chunks. And we use the recursive character text splitter class to do this. So I used instantiated here with a chunk size of 500, so pretty large chunks to be honest, and also a chunk overlap of 500. And now we can split the documents, and the documents are just the documents which were loaded in memory from the loader class. Okay, we're just gonna do this now. And this was pretty fast. And for example, now we have got a document class with a property page content where you can see the question and so on and so on. We just retrieved the first element here. So now we've got the chunks, but we still don't have the embeddings. And we need an OpenAI embeddings model to make embeddings from texts. So we just instantiate the OpenAI embeddings class here with the OpenAI API key. And then we use the face class here, and we use the class method from documents to create a vector store. And this will store the documents and the embeddings, so that we always know which embedding belongs to which text. So we just run this, and then we serialize the vector store as vectorstore.pickle and just dump it here on the file system, so we can load it later and don't have to always make the request to the API. Okay, and now we're gonna just load the database again, just to have it in memory. And first we're gonna create a prompt. This should be quite familiar to you now. And we just say you're a helpful assistant for our restaurants, nothing else. So just run that. And then we will create a chain. And we will use a new chain, the retrieval Q&A chain. So a chain specifically for question and answering with a vector database. And what we're gonna do now is create an instance here with the from chain type. We pass the LLM and also a chain type. And the retriever, which was created here, this is the vector store, is the vector store, which now has a as retriever method to allow retrieving documents easier. And we just pass in the prompt here as keyword arguments, because otherwise it would not be possible to pass this here. Maybe this will be easier in the future. So we now ask, when does the restaurant open? This will be our query, and we use the run method from the retrieval Q&A chain to run the query. And then we will first make the request, and we can see our restaurant is open from 11 AM to 10 PM. And this was just retrieved from the database via similarity search. Okay, this works fine, but what if we have some follow-up questions here? We already learned the concept of memory, and we're gonna use the memory here and just instantiate a memory, a conversation buffer memory. And then we use the memory inside the chain. So as you can see, I now have a conversation retrieval chain. This is a similar class to the normal retrieval Q&A chain, but this class is not able to handle memory. So we have to use this conversational retrieval chain here. But it works very similar. We create an instance of OpenAI. Now we use a more complex or more expensive model with TextDaVinci and just give it here the memory. And again, we have to also pass the vector store as retriever and also the prompt. And now we run the query. Do you offer vegan food? And we will receive an answer from the bot, and we will ask how much does it cost. And without the memory, it would not be clear what it actually means. But now we know that it refers to the question before, to the vegan food. And the model should be able to retrieve the correct information from the vector database. So okay, now we can see our vegan options range in price from $12 to $20, depending on the dish. So everything works as expected again. After taking a look at indexes, we now take a look at agents. Agents use an LLM to determine which actions to perform and in what order. An action can be either using a tool and observing its output or returning it to the user. To use an agent, in addition to the concept of how an LLM chain works, it is important to understand a new concept, and that is the concept of a tool. But before going into the coding concepts, we'll also learn another concept, and this is the concept of the prompt of an agent. An agent makes use of, for example, a so-called React framework, and React stands for reason and act. So the question here will be divided in a thought, and the thought will be then splitted inside different actions. And the agent will now take different thoughts and different actions to actually get the result. So it queries the LLM multiple times, so in multiple iterations, until it gets a final answer. This may be very powerful, but of course you also lose a lot of control of how the agent works, and you may get unexpected results. So be careful when using agents. A very popular project for an agent is the AutoGPT project. Maybe take a look at that if you're interested in an already working solution for this. Okay, now we have a look at tools. What are tools? Tools are functions that agents can use to interact with the world. For example, this can be some search utility or math utility, and LangChain already provides a set of tools that are easy to use and just ready to use via the load tools function. And for example, here in this code, we want to have the math tool, the LLM math tool, and we can just use the load tools function to load a list of tools. And in our list of tools is currently just the LLM math tool. And we also have to provide an LLM class here, which will be TextDaVinci 003. So now we've got our tools. If we run that, and as you can see, we've got a list with a name and a description. The same pattern like, for example, in the response schema, always a name and a description. We could also do it like this when we import the tool class and create a tool list here and instantiate a tool with a name and also with a function. And this is currently just the run method here from the LLM math tool. So this works out of the box because normally every tool has to make use of a run method. And then we've got a description tool to calculate, nothing else. This is just for demo purpose. You don't have to run this code actually. And now we initialize an agent. We import from LangChain agents the initialize agent function, and then we pass the tool list, the LLM, and also the type of agent. And I already showed you what the React framework is, and we use the zero-shot React description agent. And now we ask, how are you? And now the agent should evaluate if this is a math question or not. Entering new executor chain, observation, none is not a valid tool. Final thought, I need to use a different tool. Final answer, I'm doing well. Thank you for asking. Okay, so now we've got a math task. What is 100 divided by 25? If you run that, the observation should be, I need to divide two numbers, and then the action is the math tool. And now the math tool is used, and we get our final answer, 100 divided by 25 is 4. Okay, but what if we want a tool that retrieves information from our vector database? This is nothing LangChain already provides for us. So we have to write a custom tool. What we're going to do for this is we import the base tool class and we create an own class which inherits from the base tool class. And we have to give a name and a description as class property. And again, name and description, very important for the LLM, especially the description. Useful when you need to find an answer for our restaurant. And then we have to define two functions, the underscore run method and the underscore a run method. This is for asynchronous tasks and will not be implemented here. But we have to define this a run function. This a run function takes one argument, one which we have to use, and this is the query. So this will be a string. And what we're going to do here with this query is first we're going to create a retriever. So we use the vector store as retriever function, make a retriever here, and then use the retriever to get the relevant documents and pass in the query, the question, and this will be embedded. And we get back the most similar documents from the document store. This will be a list of documents, and we can extract the page content from the document class when iterating over the documents, and then just return it with a new line for every text we get from the database. So this underscore run method will be actually called by the run method under the hood. So this will be overridden. Okay, just call it. And then we import the agent type class here because we have to define the kind of agent here. It's just a little bit different than doing it like this here. We can also do it like this. And as tool, we used our custom search tool. This is the name of our class. We instantiate it here and then pass it as tool list to our initialize agent function. Okay, let's run this. And now when does the restaurant open should return the relevant information from our database. And the agent should also use our custom tool here. Okay, now we can see action restaurant search. And here we get our data back. This is the formatted documents from the database. And now the thought is I know the opening times of the restaurant. And here we get our final answer. And the answer is here. Our restaurant is open from 1 a.m. to 10 p.m. from Monday to Saturday. Very nice. Okay, now you learned about agents, and now we're gonna have a look at how ChatGPT plugins work under the hood. ChatGPT plugins under the hood use the concept of agents, but they don't just talk to a database, they talk to an API. For example, I've provided you here with an example for the Klarna API. Just gonna read our environment variables first, and we also need some classes here which we didn't use yet, like the AI plugin tool and the chat OpenAI here. So again, we're gonna load these classes, and then we retrieve the URL here, the AI plugin.json file. This is the exact file every plugin has to use, and we retrieve that as tool. So we save it in the tool variable, and I'm just gonna show you what's inside this plugin.json file because it's publicly available. Okay, here is it. And as you can see, there is a description for a human, and there's also a description for model. As you can see, the description for the model is much longer. And yeah, it's just like an assistant that uses the Klarna plugin to retrieve relevant product information from the shop. So this is the information the LLM has now about the tool. And this will be used from this website here. To make requests with LangChain, we need a tool which is provided by LangChain, and this is the request all tool, because we make a GET request to this API endpoint provided by Klarna. So we have to make it available inside our tool list. So we have our tool here, and we also have the request all tool. So we've got two tools for this agent. Then we again create our agent with the initialize agent function, provide the tools and the LLM, and then just query here what shards are available in Klarna. So the agent should be able to make a request autonomously to the Klarna API. And as you can see here, already the thinking process started. The OpenAI spec is red. And now we can see it tries to retrieve the information. Yeah, but it failed. To be honest, as we can see, the model's maximum context length is 4097 tokens. To be honest, the messages here were longer. And this is something which is not fixed currently by LangChain or by the team which wrote LangChain. And yeah, currently it does not work as expected. I tried it multiple times, and unfortunately it failed multiple times. This is the exact code from the documentation, but it doesn't work yet. But I think it's still useful to know about this kind of workflow to get an AI plugin or JSON file and use it as tool for our agent. This will be always the same, and I hope in the future this code will be fixed. Okay, let's now take a look at our last concept, and this will be evaluation. But actually how to evaluate the output of an LLM. This is not as easy as a math problem. For example, if we calculate 2 plus 2 and our calculator outputs 5, we know the output is just wrong. Or for other machine learning techniques, we have some kind of accuracy, but for LLMs, it's not possible. For example, we could calculate some string similarities, but for sentences which are not similar, they still could have the same context. And yeah, it's just very difficult. One approach is to actually use an LLM with few-shot prompting. So we provide some examples to let the LLM evaluate its output by some examples. So let's load the variables again here. So after loading the API key again, we will create a prompt, and now the bot should have a special identity. You are an expert professor specialized in grading students answering to questions. And here's the query, and here's the answer. So we will provide some query and some answers, and we will also provide the result. So what grade would you give from 0 to 10, where 0 is the lowest, very low similarity, and 10 is the highest. So we'll just create that prompt here, and we will create some examples for this prompt. So we will create a question and a context. So okay, now we have these kind of examples, and we will create another prompt, a Q&A prompt, where we've got the context and the question. So just these two pairs here. Then we will create a new prompt template and let an Q&A chain run over this and make some predictions here. So we're just gonna make our predictions with these inputs. And now we can see, yes, we offer vegetarian and vegan options. This is the input, and this is the real output, and this is the predictions. And now we use the LLM to let it evaluate if it's similar enough to be true or false. So if you run this, we can see we get correct and correct. So we let the LLM evaluate if the predicted text here is correct or not correct. So we don't have any fancy metrics, but we just use the prompt and the LLM to actually let the LLM evaluate our predictions if everything works as expected. And we could just run this example now for multiple different models, and now we could calculate how many of the predictions are correct and then take that model as our model for production, for example. Okay, that's it. That was quite a lot of content. Feel free to play around with the notebooks. And if you liked the video, subscribe to my channel and give the video a thumb up to help the algorithm. Thank you very much. Bye bye.